Let us see verticals traversal of binary tree. We need to traverse the binary tree in the vertical form. So we need to print the nodes that are on the leftmost vertical line, then next vertical line, the next vertical line, then the rightmost vertical line. How do we decide that two nodes are falling into the same vertical line? We use the concept of horizontal distance. Root is considered at horizontal distance 0. This is at -1. This is at +1. And when we go to the left child, we reduce the horizontal distance by 1. So this is +1, left is going to be 0, +1, -1. And right is going to be +1, +1, +2. When we go to the right child, we increment the horizontal distance. When we go to the left child, we decrement the horizontal distance. Now if you see, these two nodes have the same horizontal distance 0, 0. So they fall into the same vertical line. And if we draw the vertical line, we can notice that they are falling into the same vertical line. So we print the node 20 first, which is the leftmost vertical line. Then we print these two nodes, 10 and 40. They are falling into the same vertical line. Then 30, then 50. When we are printing nodes of a particular vertical line, for example, this vertical line, we need to ensure that if a node comes above in the level, that should be printed first. This is level 0, this is level 1, this is level 2. So this comes below the level, so 40 should be printed after 10. And if there are two nodes at the same level, for example here, 5 and 6 are at the same level, then we need to give preference to the left child over the right child. Let's now see this. In this example again, this is horizontal distance 0, this is -1, and this is again 0. So we have two vertical lines here. So we are going to print 10 and 20 and then 10, 30. Please note that when we are drawing binary tree pictorially, we may not draw this tree in such a way that everything, graphically lies into the same vertical line. But we can always use the concept of horizontal distances to decide which nodes are falling into the same vertical line. Let's see this tree. So we have 0, -1, then -2, then we have 0, then we have +1, then we have 0 again here, then we have +2, then we have +1, and then we have 0. So these nodes have distance is 0, they are falling into the same vertical line, right? They fall into the same vertical line, all these four nodes, right? And this falls into a different vertical line, this falls into a different vertical line, this, and this. So our output is going to be this vertical line 4, then 2, then 1, 5, 6, 9, then 3, 8, and then 7. Now please pause this video and try to write down a function that takes root of a binary tree as argument and prints nodes in vertical lines, but does vertical traversal of the tree. In case you have not seen the vertical sum video, it is strongly recommended to first see the vertical sum video before trying the solution. Let us now talk about the idea of implementation. We want to maintain nodes in sorted order of horizontal distances because we want to print the leftmost vertical line nodes first, then the next node and the next node. So we use a tree map in Java or map in C++, which is a self-balancing binary search tree and maintains key value pairs, and items are sorted according to the keys. So we use horizontal distance as a key into this map or tree map, and we use nodes or array of nodes as values in this tree map. And now how do we fill this map? To fill this map, we use level order traversal. And in this particular question, we must use level order traversal because the top level node should appear first in the output before the bottom level node. This should be printed according to levels. And level order traversal takes care of left right automatically. If there are two nodes at the same level, then level order traversal is always going to process the left node first, right? So that order is also maintained. Let's now see the working of this. We create an empty map in C++ and tree map in Java. And in this map, we are going to have key value pairs where our key is an integer key, right? And our array is or vector in C++ as value, or array list in Java as value, right? So that's how this map is going to be, right? It's going to have an integer key and array as value. Now we do level order traversal and we want to build this map for this tree. For -1, we are going to have only one node 20. For 0, we are going to have two nodes 10 and 40 in the same order. 10 should be first and then 40. For 1, we are going to have 30. For 2, we are going to have 50. Now we need to simply traverse this map and print the contents. So since map is sorted, when you traverse it, you are going to traverse this first, then this, then this, then this, and you are going to get your desired output. Now we get an idea of the algorithm. Please pause this video and try to implement this algorithm. Let us now talk about the implementation of efficient approach. So we're maintaining two data structures in this implementation. One is queue and one is map in C++ and tree map in Java. So queue is a queue of pairs where every pair has two things. It has a node, reference in Java and pointer in C++, and a horizontal distance. So the idea is this. We are going to do level order traversal. When we take out an item from the queue, we are going to use its horizontal distance to find the horizontal distances of left and right children of it. And then we are going to put these horizontal distances into the queue. That's why we don't have a single node in the queue. We have a pair with node and horizontal distances. The other data structure that we have is map. In map, we are storing array of nodes or array of values which are there for a particular horizontal distance. So basically our map is final desired output. Map is sorted, and in this case, final our map will be, these are the horizontal distances in this case, 0, -1, -2, and then you have 0 and 1. So in your map, your final output will be -2 corresponding we will have 40, -1 corresponding we will have 20, and for corresponding to 0, we will have 10 and 40, and corresponding to 1, we will have 30. So we'll use horizontal distances as key in the map, and we'll have value as array list in Java and vector in C++. So if we see the map implementation, we have horizontal distance as key and array list as value. In C++, we have integer value horizontal distance as key and vector as value. That's how we have created a map. After creating these data structures, we follow simple level order traversal. We first enqueue root into the queue, right? So we have this line where we are enqueuing the root, right, as a pair, and we are enqueuing root here in the C++ implementation as a pair. Now we do level order traversal, standard loop, while queue is not empty, and inside this loop we take out an item from the queue. Let's understand this implementation with this example. So we take out an item, and we take out the item 10 because this is what we pushed initially. So we take out 10, 0 from the queue, and our current item now becomes 10, and our horizontal distance is distance of this node. So we compute these values once we take out an item. Same thing we are doing in C++ code. Now, after doing this, we are checking if our map contains this value. So our initially map is empty, map does not contain it. So we are going to put a key value pair in the map where the key is horizontal distance and value is an array list in Java and a vector in C++. So now we have one entry in the map, and this entry is for horizontal distance 0. We have an array which contains, here we have 10, which contains 10. Now, after we have processed this extracted key from the queue, so this is all processing the extracted key here, and this whole part is there. If the key does not exist, we create a new array list. That's what will happen when you process 10. If it does not exist, you will create a new array list, and you will add this item to the array list, and you will put it into the map. And in C++ implementation, we can simply do pushback. It's simpler because the way maps work in C++ is, if this entry is not there, then they create an empty entry, and an empty vector is created, and you can push the data there. So C++ code is less, and Java code is this much to handle both the cases if key already exists and does not exist. So this is what happens when you take out 10. And after that, you push left and right children of 10 to the queue, right? That's what we are doing in this C++ implementation and this Java implementation. So now our queue is going to have 20 with horizontal distance is -1. When we enqueue the left child, we do SD -1. When we enqueue the right child, we do SD +1. And the next item in the queue is going to be 30 and 1. So this is one iteration of loop. After one iteration, this is all will happen. And then we do the next iteration. And in the next iteration, we again take out an item. and this time our current is going to be 20 and our HD is going to be -1. After taking out this item, we again see if this exists in the map or not. HD -1 does not exist in the map, so we are going to enter one more value in the map. So our map is now going to contain 0, 10, and the next entry in the map is going to be -1, 20. That's what our map is going to contain. It's 0, 10. So we have extracted 20 and we have processed it. We have processed this here and this part is done here, right? We have removed it from the queue. Now we are going to enqueue its left and right children. So now our queue is going to have 30 was already there in the queue. 30 and its horizontal distance 1. Now we are going to have children of 20 also. So we are going to have 40 and horizontal distance for 40 is going to be -1, -1, -2. And horizontal distance for 50 is going to be -1 + 1, 0. So this is how our queue will look like after we have processed 20. We had processed 20 and our map looks like this and our queue looks like this. Now we take out the next item from queue, which is 31, and we process it. We check, do we have an entry for key equal to 1? We do not have an entry for key equal to 1 in the map. So we are going to add an entry into the map and our map is going to look like this now. We'll have 0, 10, we'll have -120, and then we'll have the third entry, which is for 1 and 30. Please note that I've not written the entries here in sorted order, but internally map is a self-balancing binary search tree and it's going to maintain the sorted order. So -1 is going to be first, then 0, then +1. So I'm just writing them in the order they are added here for ease of understanding. Now we took out 30, so we'll enqueue the next items. Children of 30, and 30 does not have any children, right? So we are not going to enqueue anything. Our queue will now be 40, -2 and 50, 0. So these conditions will become false and we will not go into if condition for 30. Now we'll take out next item from queue, which is 40, -2, and there is no entry for -2 in the map, so we'll add 40, -2 into the map. So we'll have 0, 10, -1, 20, 130, and then we'll add -2 and 40. A new array is added, right? And so we have taken out this item. Now we have this in the queue, only 50, 0. And this time we are going to see a different behavior because 0 already exists in the map. So what are we going to do? We are going to add this 50 to this array and our final map will look like this. Map equal to 0, 10, 50. So we'll have two things at key 0, right? And then we'll have -1, 20, and then we'll have 130, and then we'll have -2, 40. Now what all we need to do is we need to print the content of this map, and this map is internally maintained in sorted order. So this is going to be first, then this, then this, then this. So we need to simply traverse this map and print the contents line by line. That part I've not skipped here. Now I'm going to talk about printing the map part. So we have built the map. Map contains these items. Horizontal distance is key and an array of values is a value in the map. So we have key value pairs in the map. And they are sorted in increasing order of keys, -2, -1, 0 and 1. Now we simply need to print the content of this map line by line. So what are we going to do? We are going to traverse through all the keys one by one, -2, and then we are going to print this array, right? Then we are going to print a new line. Then we are going to come to this key, print this array and print a new line. Then we are going to come to this key, print this array and print a new line. Then here, come to this key, print this array and print a new line. So we are going to print the first thing 40, then new line, then 30, then 10, 50, then again a new line, and then finally 30. And this is the code in Java, and this is the code in C++. In Java, we have a map where integer is a key and array list is a value. So we get all the things in map using mp.entrySet. We get the value for every pair that we are getting. Where pair is key value pair, key is integer and value is array. So we get the value, and now we traverse through all the elements of array list. We print all the elements and print a new line after it. And same thing we are doing in C++. We have a map, we traverse through all the entries in this map. So we get a pair for every entry, and we get the value of this pair or value in this map using p.second, right? So p.first is your key, horizontal distance, and p.second is a vector. Now we traverse through this vector and print content of this vector, and after that we print a new line. So that's how we get vertical traversal of binary tree.